Now let us continue. That is the relative strength of acids and bases. We try to understand the relative strength of the given species to behave in acids based on the structural aspects. So by studying the structure of the given molecule, so we try to report which substance is more acidic, like that. So there are certain factors are there. That factors is helpful in order to define which acid is stronger or weaker. So as we know, structural effect to say the relative strength of acids and their conjugate bases. So the main part is the structural effects. So to say the relative strength of acids and their conjugate bases. So the topic is structural effect to say the relative strength of acids on their conjugate bases. So let us consider, for example, we have an acid given by Ha, and the strength of that acid is normally defined in water. A transfer of proton from this acid to water, which gives rise to A minus H3O plus. So the strength is normally dictated by the equilibrium constant in order to say the nature of this substance. So the equilibrium constant or Ka. The equilibrium constant, it is also referred as dissociation constant of an acid, Ka. So what is the expression of Ka? The expression of Ka is, you can write the product concentration divided by reactant concentration. So this is the expression of Ka. And here normally to say the strength of the substance, like here the taken acid. So in order to say the strength of this acid, so the Ka value is helpful. As higher the Ka value, the acid will be stronger. And otherwise pKa value is also pKa. That means pKa is given by minus log of Ka. So by these two parameters, we'll say the relative strength of the given substances. Higher the Ka value, the relatively stronger acid. In other words, so pKa value will be lesser, that is a stronger acid. Whenever Ka is higher, the pK will be lesser. So now our aim is, actually this is a part of conjugate acid-base theory, and the concept of this is already we have discussed under the part of conjugate acid-base theory. But now our aim is to focus over how the structure of the molecule have influence to dictate the acidic strength of the given molecule and also the basic strength of its respective conjugate base. Now let me say the factors. So what factors is helpful in order to transfer the proton by the taken acid? In order to eject the proton by taken acid, there are certain factors are supported. So based on the factors, we can able to say which given molecule, which one is more acidic, like that. So let me say the factors. Factors influence the acidic strength. The factors influencing the acidic strength of the given substance. There are different factors are considered. Those factors, if we are able to analyze those factors, which is helpful to say the relative strength of the given species. Now the factors are, let me say there are the different factors, and that one of the factor is bond enthalpy of HA, the bond energy. The bond energy of HA, where HA is nothing but acid. Our aim is to say what is the strength of this HA, where H refers to a proton. So there are different species which are supposed to have the proton. So in what better manner they will eject the proton, then the strength will be higher. So the ejection of proton is decided by one of the factors, bond energy of HA. And we have the factors and bond polarity. First priority we have to check bond energy. The next we can go for bond polarity of HA, which is normally depends upon the electronegativity of the atom, where the proton is supposed to be ejected from that element. So the bond polarity of HA, which is influenced by electronegativity of the element. Electronegativity of element. From that, the proton to be ejected. Proton to be ejected. So we can say one of the factors is bond energy of HA, another factor is bond polarity of HA, which is influenced by the electronegativity of element. From that, the proton is supposed to be ejected from that substance. And the third factor, let me go, it is about the stability of the conjugate base. It is an acid, its conjugate base is A minus. Now what is this one? It is a conjugate base. You know the acid and base which differ by proton is referred as a conjugates. So which is an acid and it is a conjugate base. So the stability of conjugate base is more and more, then the reaction is derived more extent to the right side. That means the acidic strength of HA will be increases. So the next fact is the stability of its conjugate base. Stability of conjugate base. Conjugate base here A minus compared to acid HA. That means there may be stability you can consider even for acid and its conjugate base. But if base is more preferably stable than the acid, then the reaction is driven to the right and the strength will be higher. And the stability of conjugate base is more when compared to the taken reactant, that is an acid. Then the reaction is driven to right, that means more of proton is transferred, the more ejection of proton, then acid strength will be higher. So the stability of conjugate base is also one of the important factor to say the strength of an acid. And finally the last factor is, we can say the nature of solvent. Nature of solvent. We have the solvents like polar and non-polar, and which solvent is more appropriate in order to run the reaction. So in order to dictate the acidic strength of the taken acid. So these are the factors. Now with reference to each factor, let us take some questions. Otherwise, let us take some examples. So to illustrate how the factor have influence to give the report of the relative acidic strength of the given species. Okay, now let me take examples with reference to bond energy of HA. And this is the trend normally noticed in the compounds of the elements, the compounds which are resulted from the elements of a particular group. So which is normally noticed a particular group, the compounds which are resulted, compounds of elements of a group. See, for example, let me take some compounds where it's supposed to have ejection of proton. So the substances like, let me take halogen acids. Halogen acids which are nothing but the compounds of group 17. What are the halogen acids? Let us take the list of halogen acids. The list of halogen acids is nothing but we have like HF, HCl, HBr, HI. So these are the halogen acids. Otherwise, these are the compounds resulted from which elements? The elements of a particular group. The compounds of elements resulted from a particular group. So, because in any group, as the size of the element is increases, that makes the bond length is increased, and as bond length increases, is easy to break. I want to say that in any group, as bond length increases, the bond energies decreases. So that means among these substances, which one breaks bond easily? So this one breaks bond easily, and it gives rise to I minus by ejection of protons so easily. So just it ejects the proton and gives rise to I minus compared to this one. So I can say as bond energy is decreases from top to bottom, HI is considered as a stronger acid. Otherwise, this is a substance which ejects proton easily. So in this reaction, if we take HI and HF, the HI transfer proton easily to this, and value of Ka will be highest. So based on the bond energy, we are just reporting the result. So in this case, HI is a stronger acid and HF is a weaker acid. Okay, so I can say the strength of acids will be increases. So the order of acidic strength will be HF is weaker acid than HCl, which is weaker acid than HBr, which is weaker acid than HI. Here we can also explain this factor based on electron density of its conjugate base. This is acid, these are acids, and what about these are conjugate bases? These are conjugate base. So what is conjugate base of this? F minus. We just think that here this is less preferred to move this side, and I can say because it is more preferred to get back to HF, we can say based on electron density of those conjugate bases. If you look here, it is having the electron density and it is a small in size, that's why the high electron density over that small portion, that makes the high electron density makes to gain the proton is more preference and get back to HF. That means what we can say, it behaving as a strong base, because gain of proton means it's a function of the base. So among these two, which is more preferred to gain the proton based on the electron density? I can say other than this bond enthalpy, we can also say based on electron density is also considered. If you think about electron density, so this factor is higher for this. That means it is more preference to take the proton and get back to HA. That means the F minus is a stronger base compared to I minus. As for conjugate acid base theory also we can say, as I already told, in this list, this is a stronger acid. Then what is its conjugate base? Weaker base. Because it is more preference to eject the proton. That means we can say its conjugate base is less preference to gain the proton and get back to original acid. So like that, the bond energy of HA is helpful to say the strength of acids and also the strength of respective conjugate bases. As the strength of acids is increases, in this case here the strength of the conjugate bases also increases from down to up. That means among these four substances, what is the order of acidic strength? We can say HA is stronger than HBr, which is stronger than HCl, which is stronger than HF. This is acidic strength among the acids. We have taken a compounds of elements of group 17. Now let me take the compounds which are resulted from group 16. So from that also we can try to answer the question. Okay, now if we take the elements of group 16, the group 16, the 16th group, what are the elements of group 16? Oxygen, sulfur, selenium, tellurium, and polonium is radioactive, let me leave it. So what are the compounds resulted where the proton is supposed to be present? That is nothing but hydrides. So the compounds are He2O, H2S, H2Se, H2T. These are the compounds of the group 16. So in this case, once again, as the element size increases, bond energy will be decreases. That means which is more preferred to give the to eject the proton. So this is more preferred to eject the proton, and gives rise to this one. Okay, so this is the conjugate base. These are acids, these are conjugate bases. So based on the bond energy, I can say this extreme down compound is a stronger acid and the respective conjugate base is a weaker one. That means more preferred to go forward and with less preference to get back to that one. Because the size is more, the electron density is very less. That means it is less preferred to take the proton and get back to original acid. So based on electron density also we can compare the strength of the conjugate bases. Anyway, this gives the information of this part also. In this case, the bond energies are decreases, acidic strength increases because it is a conjugate thing. When it is a stronger acid, it is going to be weaker base. Like that. So what is its conjugate? Its conjugate will be, I can say HO minus, OH minus. So you can say this is here I want to say that this is a stronger acid, and here it is going to be weaker base, conjugate base. In this case it is comparatively weaker acid, so it is going to be comparatively strong base. That means it is more preferred to get back compared to move forward, because the small in size, electron density is higher, so it prefer to take the proton and get back to acid. So like that, the bond energy or the electron density of the respective conjugate base is helpful to discuss this part. Okay, let me take the elements of group 15 also, the compounds which are resulted from group 15. We can give the order of acidic strength. So if we take the compounds resulted from group 15, the elements are nitrogen, phosphorus, arsenic, antimony and bismuth. So what are the hydrides are there? The hydrides is nothing but NH3, PH3, ASH3, SbH3 and BH. So these are the compounds of one particular group. Thereby we can say the size of the elements increases, otherwise the length between a metal to hydrogen, the bond length increases. That means it is easy to break. If you just take the sticks of a shorter length and longer length, the longer stick easy to break. So in that way you can say as the bond length increases, the bond energies are decreases. That means this is said to be a stronger acid. This can eject the proton easily and gives rise to its conjugate BiH2 minus. Okay, so from this the acid strength increases. Otherwise this is a stronger acid and otherwise this is a weak base. So in this case this is relatively weaker acid and its conjugate base is what? NH2 minus. So in this case this is a weaker acid, then it is going to be a stronger base. Like that. It means acidic strength top to bottom increases. In the respective conjugate bases, the basic strength down to up increases. It is the specialty of conjugate acid base theory. If we know the relative strength of acids, then it is helpful to report the relative strength of their respective conjugate bases. Okay. So the protonated form of these compounds. For example, let me take compounds like a nitrogen. It is something like let me take it is a amine. It is a derivative of ammonia. We have ammonia. When ammonia hydrogens are replaced by alkyl group, then it is referred as amines. Of course, it is a tertiary amine. And in this, if suppose it is protonated, we get this one. And let me take a compound of phosphorus. So if we take the phosphorus, similarly let me take the substituted phosphate. PH3 means phosphate. If it is substituted with some alkyl groups, it is called trialkyl phosphate. And if it is once protonated, like this. So I can say this is a protonated form of amine. This is a protonated form of phosphine compound. Okay. So among these two compounds, which is stronger acid? That means which is more preferable? If we take this and this in this position, which one transfers proton to water easily? So that is once again, as these two elements, the proton is linked to elements of nitrogen and phosphorus, which are the elements of group 15. So in this case, once again, based on the size, we can say the bond length is supposed to be more here compared to here. So based on once again the same factor, bond energy, this bond is easily to break. So as this bond is easily to break, I can say here this is a stronger acid. Among these, this is a stronger acid and this is going to be weaker acid. What are its conjugate bases? After rejection, what it will result? It will result this one, trialkyl phosphate. What is the result of this? Trialkyl amine. It is an amine. So in this case, I want to say this is more preferred to go to this preference to eject the proton like this. Otherwise, the phosphorus is big in size, the electron density is less compared to here. So that factor also says that it is more preferred to get back compared to going like this. So in this way, we can understand that the bond energies are helpful to decide relatively which is a stronger acid and weaker acid. Once you must be able to say among these two, this is a stronger acid, definitely its respective conjugate base is a weaker base. So it is a weaker base and it is a stronger base. So the basic strength increases in this direction, the acidic strength increases in this direction. Okay, even protonated form of the compounds also we can take just by considering the elements. So the proton connect to what element and what about the position of those elements. If the position of the elements will of the same group, then we can go for this factor, that is bond energy. Oxygen and sulfur, both are the elements of group system. And let me take here, it is an ether. Let me take here a compound like anything, either hydrogens or substitute with some alkyl group, anyway. So if it is protonated, we get this one. If it is protonated, get this one. So these are the two compounds, the protonated form of oxygen, it is called oxonium. You can say it is called oxonium salt. Ether is once protonated, it is called oxonium ion. And this is a sulfur compound, it is also protonated. So in this situation, once again based on the bond energies, you can say as the sulfur size is bigger than oxygen, this bond is easily to break. That's why you can say acidic strength increases in this way. And what are the respective conjugates? This is the respective conjugates. So as I am saying, this is more preference to go like this, and this is a stronger acid, this is a weaker base. Here it is less preferred compared to like this. Okay, among these two otherwise. Among these two, this is acidic strength increases, here the basic strength is increases. So among these two, which is a stronger base? This is stronger base compared to this one. Among these two, this is stronger acid compared to this one. So based on the same idea. So now in this way we can think about the first factor, which is helpful to give answer for few persons. Now let me go to the second factor, bond polarity of HA. That means the hydrogen linked to a particular element of the acid. So the bond polarity depends normally by the hydrogen linked to which kind of element. But element, what about its electronegativity? So that factor normally considered, this is the situation normally considered the compounds of the period. The compounds which are resulted from the elements of a particular period, where the sizes of elements is not that much difference. Then the electronegativity is helpful to consider the polarity of the bond. Okay, now let me take an example. Okay, so in order to consider the second factor, let us take some examples. So we take elements of a particular, for example, if we take the elements of the second period, because we are considered is a periodic trend. It is like elements we take like second period we have carbon, nitrogen, oxygen and fluorine. Now let us take the compounds of these elements. So it forms a compound like HF. It forms compound like H2O. It forms a compound like NH3. It forms a compound like CH4 because it is monovalent, divalent, trivalent, tetravalent. So these are hydrides of the second period elements. So in this situation, the sizes is almost same because all the elements of the second period, the valency shell of all the elements of the central atom here it is of shell number 2. That means valency shell of the elements will be second. So there is no much difference of the size, then the electronegativity is helpful. What happens electronegativity, and moving left to right, the electronegativity increases. Electronegativity is increases. So as electronegativity increases, I can say the bond polarity will be more. Just take here carbon to hydrogen bond and H to fluorine bond. As fluorine is more electronegative, which withdraws the bonded electrons more towards that means the extent of polarity will be more. So based on the electronegativity of the element to where to that hydrogen is attached, that hydrogen is supposed to come out as a proton. So that makes the acidic strength. As bond polarity is more here the ejection of proton is so easy. So compared to this one. Because fluorine is, what is the electronegativity order? The fluorine is highest compared to oxygen, which is highest compared to nitrogen. So as the electronegativity of elements is increases from carbon to nitrogen, nitrogen to oxygen, oxygen to fluorine, you can say the bond polarity is highest here. That makes the breaking of bond is easier, ejection of proton is easier. So like that, you can give order of acidic strength will be like this. This is the order of acidic strength. So here the bond polarity, that means electronegativity of element where proton is, from that element proton supposed to be ejected. So let me take for example the compounds of third period. If we go for compounds of third period, what elements you will get under carbon? You will get silicon. This is phosphorus, sulfur, it is chlorine. So let us take the hydrides of these elements. What are the elements you will get? Here you get HCl, here you get H2S, you will get PHA3, you will get SiH4. Let me write this. So in this case, which bond is more polar? Once again, the electronegativity increases from left to right. That's why this bond is more polar. That makes the ejection of proton is so easy here. So what happens to the strength? So the strength will be like this. So HCl is stronger than H2S, which is stronger than PHA, which is stronger than SiH4. So in this way, we can give order of acidic strength for the compounds where the proton is supposed to be ejected from the elements of a particular period. So then bond polarity is a considerable factor to report the acidic strength of such compounds. Okay, now let me take some other examples. See, sometimes the element may be the same. For example, there is some situations of the compounds, the elements may be the same. For example, if we take element carbon, here we have 1s, 2s, 2p. So this is the configuration, and normally if you look at the time of bonding, it will involve excited state configuration, and normally in its compounds you have the option of taking sp hybridization and sp2 hybridization, sp3. There are different options are there, sp, sp2 and sp3. So there are the compounds where the element carbon have different hybridizations. For example, you take, for example, under sp3 you take a compound like alkane, an alkane. So this is an alkane, sp3. If we take a compound like alkene, this is sp2. If we take a compound like alkyne, so here the proton is supposed to be ejected from the carbon, but the element is same, but the nature of that element is different in that compound. That means the hybridization is different. What about the hybridization? This is having of sp3, it is sp2 and it is sp. So as we can say, that means whenever in the case of hybridization, in the case of, for example, if we take sp3 hybridization, the s character is 1,4 and p character is 3,4. But if we take sp, the s character is 50%. That means in the case of compounds of carbon with sp, whenever hybridization is sp, the s character is more. That means the nuclear character will be more, because s orbital is located very near to the nucleus, and the nucleus power makes the electronegativity of such element is highest. Here I am saying that the electronegativity of sp hybridized carbon is highest compared to sp2, compared to sp3. So the hybridization is also influenced to alter the electronegativity of a particular element. based on S character. As S character is more and more, the nucleus character will be more, then electronegativity will be more. So based on that I can say this carbon is highest electronegativity and here the polarity will be maximum. So based on the polarity, the ejection of proton is so easy in this case. So that's why the bond polarity increases from alkene to alkene, alkene to alkyne. So which is a more acidic compound? The alkynes are more acidic compared to alkenes. So which is more acidic compared to alkane? So here the element is same. The proton ejected from particular element, but that element we have exhibited with different hybridations. So based on that we can say which is a stronger acid. Now with reference to this hybridization, let me take some other examples. So other than the carbon, let me take the situation happens for oxygen. Otherwise if you go for, let me go for nitrogen. If we take the compounds of nitrogen, nitrogen will have the situation like of having a valency of like this. It is a protonated form of, normally nitrogen is a trivalent. Once it is protonated tetravalent, we get the formal charge of positive. And there are some compounds which have double bond. The situation will be like this. It is once protonated, we will get this one. There are some compounds which have the triple bond. Then it is once protonated, we get formal charge. So the situation, the environment of nitrogen in the different compounds will be like this. Let me say here it is an example of amines. Amine. It is a protonated form of amine. Whenever here it is a carbon, that means whenever carbon is raised, carbon to nitrogen double bond is appeared, such compounds are called imines. Such compounds are called imines. So these are called protonated imines. Whenever there is a carbon to nitrogen triple bond, they are called as cyanides. They are also called as nitrides. So which is called protonated form of nitride. So I just taken three compounds: the protonated form of amine, the protonated form of imine, the protonated form of nitride. So then what about the acidic strength of them? Here the element is same. The proton is supposed to be ejected from the same element, but the nature of that element will be different in terms of its hybridization. So you just see here all are the sigma bonds, all are four are directional bonds. So the hybridization will be sp3 hybridization. Here one is pi bond, so three are directional bonds. So hybridization will be sp2 for nitrogen. In this case, there are two pi bonds are there, only two are sigma bonds. So the hybridization will be sp. So the nitrogen in different compounds will have difference of hybridization that dictates what is acidic strength. As you know, sp hybridized nitrogen is more electronegative compared to sp2. That means as it is more electronegative, ejection of proton is so easier. So acidic strength is increases from top to bottom. Okay, the acidic strength increases from top to bottom because it is sp hybridized nitrogen. As sp hybridized means S character is 50%. That makes electronegativity of that element is the highest. Now let me take a compound of oxygen where hybridization of oxygen is different. Suppose you are taking a compound like ketones. Let me say it is once protonated, we get this is the protonated form of ketone. You just take ethers. Once it is protonated, this is the protonated form of ethers. So here it is a situation, once again the element is same, but the scope of hybridization is different. So what is hybridization here? Hybridization of oxygen is here, we can say it is one non-bonded electron pair and two sigma bonds. One is pi bond. That means here two sigma bonds, one non-bonded electron pair. Totally three electron pairs. So it is sp2 hybridization. But in this case, three sigma bonds, one is a non-bonded pair. That means total 4 electron pairs. That makes it is sp3 hybridization. So in these two compounds, you can say that the S character is more for the first one. That is protonated form of ketone is a stronger acid compared to protonated form of ether. So acidic strength is increases like this. So this is stronger acid compared to this one, second one, like this. Now let me take one more example. Here compounds like carboxylic acid, you take compound like amides and you take compounds like ketones. Okay, now we are taking three different compounds, in that carboxylic acid, amides and ketones. So here once again, based on the bond polarity we can report. Based on the bond polarity, here carbon to hydrogen, nitrogen to hydrogen, oxygen to hydrogen, and the remaining part don't bother because the remaining part is common in all the situations. So the bond polarity, that is carbon to hydrogen, nitrogen, that means oxygen is more electronic. If you take carbon, nitrogen, oxygen and fluorine, the electronicity increases from left to right. So you can understand that this oxygen to hydrogen is more electronegative. This oxygen is more electronegative, the bond polarity will be more here. That makes this bond is here, this compound eject proton so easily. So I can say this is the first, this is second and third. So based on the electronegativity of element, we can say which is the strong acid. So adjust is influenced by the first two factors, that is bond energy and bond polarity. Now let us go for the third factor. That is, the third factor is stability of conjugate base. That means as this is more and more stable, the reaction is more drive to right side and Ka value will be higher, then the acid will be stronger. So the stability of conjugate base compared to the respective acid. So that factor, it is one of the important factor because here actually the structural aspect is involved. The structural effect is going to be studied based on different electronic factors. That is electronic factors, it is also defined as electron displacement effects, which says about the distribution of electron distribution in a particular molecule, how it is moving from one point to another point. Otherwise it says about the electron density is maximum at which particular atom in that particular molecule. So the electron density is maximum at which particular point in that molecule is explained by analyzing the structure. So that is helpful from which molecule the ejection of proton is so easier and which one is a stronger acid. So the discussion of that electronic factors or electron displacement effects is helpful in order to understand the stability of its conjugate base. And let me see what are those factors. Of its conjugate base, the stability of its conjugate base, the stability, that means the stability of this is influenced by some electronic factors. So what are those electronic factors to say the stability of this conjugate base? The stability of conjugated base is normally considered by some electronic factors. We have normally the electronic factors is of and temporary. Under permanent we have the factors like inductive effect, and we have like resonance effect or mesomeric. Resonance or mesomeric effect, and we can also consider hyperconjugation. So these are some electronic factors, and these electronic factors are said to be permanent. That means permanent means which happens within that particular molecule, whereas a temporary means which happens at the time of reaction. It happens only at the time of reaction. That means when two species come closer, at that moment these effects will be noticed. But it happens for individual molecule. That means even the species is not involved in the chemical reaction, but by analyzing how the atoms are connected in that particular species or in that particular molecule, we can able to see how the electron is distributed. Electron is moving from which point to which point. That is considered in the case of permanent electronic effect. So here we can say the properties of that particular compound is also reported based on this structural aspect. But in this case it is just studied only at the time of chemical reaction. So it is not a permanent. It is not happens for individual molecule. So under that we have the names. We have inductive mesomeric effect, and other one is You can say electromeric effect. So, and these factors right now is helpful because we are discussing about that means how every individual molecule, the structure of every individual molecule have influence to eject its proton, to make its strength as a stronger one. So we are talking about acid-base reactions. So now let me say inductive effect. Based on inductive effect, let me consider some example. See, for example, you just take in this place water. Suppose you have taken a substance like water. Water. In this case, water is taken. Now let us try to compare the two compounds like water and alcohol. So now I am trying to take a variety of compounds under each factor, that means each electronic factor is involved in order to say that is which conjugate base is a stronger one. So if suppose if you take water, what is its conjugate base? Its conjugate base will be this one, hydroxide. If you take alcohol, what is its conjugate base? Alkoxide. Okay. So the conjugate base of water is hydroxide, conjugate base of alcohol is alkoxide. Now which is more stable among the two? Here they want to say that here actually the group R is considered as an electron donating group. Electron donating group. That means first of all let me try to understand what is meant by inductive effect. Inductive effect is one, if you take one particular molecule like this, in this particular molecule these are the carbon atoms ultimately connected to chlorine. Here the chlorine is the highest electronegativity. That means this bond will be polarized, and polarity of this bond will have influence to have a little polarization or polarization of the adjacent bonds. As this sigma bond is polarized because of higher electronegativity of this element, and this bond will also be polarized but somewhat less extent. That means there is a movement of electron from carbon to chlorine because of bond polarity, the difference in electronegativity. So that makes this is also slightly polarized. But the polarization of this bond is less compared to this bond. And this polarity of this bond will have influenced the polarizing of the adjacent bonds. So in this manner, the polarization of a particular bond will have impact in order to polarize its adjacent bond. So like that it happens, the polarization happens along the sigma bonds. And ultimately there is a flow of electrons takes place from carbon to chlorine, and there is a movement of electron takes place in this direction. So the inductive effect is what? The polarity of one particular sigma bond, the bond polarity of a particular sigma bond due to presence of one particular group, which have influence to polarize its adjacent sigma bond. And of course that also once again able to polarize its next adjacent bond, but to the less extent. So in this manner of polarization of the bonds and moving away from this element, which element is more responsible to polarize the sigma bonds, this element is more responsible. So that's why the extent of polarity of sigma bonds is going to be diminished when you go away from this atom. So that's why this effect is normally noticed up to few atoms only. So it is normally noticed up to few atoms, that is up to 3 atoms or 4 atoms like that. Otherwise up to 3 sigma bonds or up to 4 sigma bonds, not more than that. So inductive effect means it is electron distribution along the sigma bonds is moving from one end to another end. That means it is moving towards one particular end where the electronegativity atom is more, like that. So whenever there is higher electronegativity atom, this is referred as electron withdrawing group. So this is an electron withdrawing group responsible for mobilizing of electrons along the sigma bond. That is happens in the case of saturated system, otherwise not in the part of pi bond. Normally it is considered along the sigma bonds. So this inductive effect is normally considered. There are two possibilities will be there. When the movement of electron takes place towards one particular group from the rest of the molecule, that means it is moving towards one particular atom. Then it is because of electron withdrawing group. So when it is an electron withdrawing group, then this group is called negative group. That is called, the effect is called minus I effect. So we have inductive effect of two types, minus I effect and a plus I effect. The plus I effect is happens, for example, you take ammonia. We have ammonia, a derivative of ammonia. In this case, if suppose hydrogen is replaced with some alkyl group, then what happens? The electron density is increases over nitrogen. So the basic strength of amines is increases because of alkyl group. That's why it is referred as a electron donating group. That means they want to say that there are certain groups which are electron withdrawing, there are certain groups which are electron donating. Electron donating groups is referred as a positive groups, and the effect is inductive effect. The movement of electron happens along the sigma bond. So that's why the groups are once again categorized as negative groups and positive groups. Negative groups means that group presence is responsible to withdraw the electron from the rest of the molecule. Whereas the positive groups means these are some groups which are able to donate electron to the rest of the molecule, which pumps the electron. So which groups presence normally noticed electron pumping groups? The electron pumping groups is normally considered as alkyl groups is considered as electron pumping groups. Alkyl groups. So even for example, you just take benzene and toluene, which is more reactive in its substitution reactions. Suppose you have taken here alkyl group, this is found to be more reactive than this. The reason is the alkyl group is pumping the electron to the benzene ring. That means the alkyl group is an example which pumps the electron along the sigma bond. Of course, here hybridization is also different, sp2 and sp3. So in this way, the alkyl groups is considered as some groups which are electron pumping groups. So I want to say that, so the higher electronegativity elements, the groups like we can consider the groups like NO2 group or NO3 plus group, and we can say CF3 group, the CF3 group, and even CN group, etc. Any element which is more electronegative, based on the electronegativity, all these groups are considered as electron withdrawing. But which are electron pumping groups? Electron pumping groups is considered as alkyl groups. Alkyl. Sometimes there is some negative groups like alcohols. Some negative groups is appeared as negative species, carboxylate or SO3 minus. Whenever the groups, I want to say that, for example, in place of chlorine, suppose there is a carbon chain, let me put here some O minus. Then this group is responsible to pump the electron like this. It is a negative charge species. So that makes here it pumps the electron. That makes we get negative here. That makes it pumps the electron further. We get like this. Further like this. So the polarization of this bond by a group, this group is called as electron pumping group, plus I group. The plus I group that pumps the electron along the sigma bond. This bond is polarized. The influence of that polarity of that bond will have the next adjacent bond, but that is slightly lesser than this polarity, and furtherly the bond is polarized, it is still lesser compared to here. So the extent of polarity gradually decreases. So it is because of inductive effect. It is just considered up to few atoms only. So like that, I am just saying that there are two possibilities of inductive effect. Possibility by particular some groups which pumps the electron, they are called electron donating groups, where the exhibited effect is called positive inductive effect. There are some groups which are more electronegative, their electrons will be withdrawn from the rest of the molecule, that is called negative effect, that is negative inductive effect. Now, we have discussed what is inductive effect. The inductive effect means distribution of electron distribution takes place along the sigma bonds, from one point to another point. That the movement of electron along the sigma bond, which makes the molecule is polar. Okay, so that is referred as inductive effect, and which is of course happens for up to few atoms only, few sigma bonds only. Right. So now, this inductive effect is helpful to discuss the acidic strength among the water and alcohol. So I am trying to discuss the comparative acidic strength between water and alcohol. So here hydrogen is a reference. It is considered either electron donating nor electron withdrawing. In place of hydrogen we are just inserted an alkyl group, because alcohol is nothing but a derivative of water. One of the hydrogen is replaced by alkyl group, then the water is said to be alcohol. As this group pumps the electron, then the polarity of this bond is minimized. Otherwise, the hungry of this oxygen is minimized by pumping the electron by alkyl group. That makes this bonded electrons pulling by oxygen is minimized. So I am just saying that the bond polarity between O and H is minimized by a particular group which is pumping the electron. So here what effect is noticed? Inductive effect, that is plus A effect is noticed. Because of positive inductive effect, I just want to say that alcohol is a weaker acid compared to water. Otherwise you just think about its conjugate bases. In this case hydrogen, here it is R. So here this R is pumping the electron. This is pumping the electron. That makes what happens to electron density over oxygen compared to here? Here electron density is increases. Because it is pumping the electron density increases. That means it is more preferred to gain the proton and get back to alcohol. That means the basic strength will be increases. Okay. So this is a stronger base. Then it is ready to get back to its respective acid. So what I am saying that as this group is electron pumps, then the electron density increases and the species will be destabilized. I am saying that among these two, which is more stable? The stability of A minus will have the impact to dictate the acidic strength of the respective acid. Among these two, this is more stable. Hydroxide is more stable compared to alkoxide, because as this group is pumping the electron, the negative charge increases. That makes this is destabilized. I am saying that hydroxide is more stable than alkoxide, because in alkoxide electron density increases, the species will be destabilized. So in that way we can conclude based on this inductive effect, the alcohols are weaker acids compared to water. Therefore, compared to this is a stronger acid, this is a weaker acid relatively. Okay. Now let us see different type of alcohols. We have alcohols, let me take like CH3OH. In this case, let me say one hydrogen is replaced by furtherly one more methyl group. Like this. So what is alkyl groups? I am saying that alkyl groups is nothing but when the hydrogen is removed from the part of the alkane, the remaining part is called alkyl. We have the alkyl groups. If you take alkane, when hydrogen is removed, it will get methyl group. If you take ethane, the respective group is called ethyl group, like that. So we have different alkyl groups. So with reference to this one, we can able to answer. So here you just see, I want to replace two more hydrogens with the alkyl groups. So in this way, I am just taking some collection of alcohols. So what is your observation here? That means in which case more alkyl groups are there. Here only one methyl group is there, but in this case, you compare here, compared to this, here one more alkyl group is there. But here two alkyl groups are there. Here three alkyl groups are there. That means the extent of donation, electron donation through sigma 1, electron donating groups gradually increases. On moving top to bottom, the number of alkyl groups is increasing. That means as electron pumping increases, the hungry of oxygen for electron is minimized and this bond polarity will be decreased. So it is positive and negative. So the bond polarity will be more decreased in the last part because of more electron donating groups are there. Okay. Otherwise, if we take with respect to conjugate bases, in this conjugate base, the electron density in this conjugate base of this part will be more and more. That makes destabilization takes place. Among the conjugate bases of all these alcohols, which conjugate base is less stable? The last one. Because more alkyl groups are there and more electron density appear over oxygen, and that is less stable. That means the respective alcohol is a weaker one. So I hope you can understand. From here, top to bottom, acidic strength decreases. Otherwise, order of acidic strength will be, this is first, second, third, fourth. This is order of acidic strength of alcohol. Otherwise, if you think about the respective conjugate bases, and if what is conjugate base of this CH3O minus, here CH3 CH2O minus, here this one, here 3 methyl groups. That means here, okay, among all these, which is less stable? This is less stable because more electron donating groups, more electron density, and it becomes destabilized because it obstructs the product together. Acidic strength is decreased. Then here basic strength is also decreases from down to up. Yes or no? So in the case of acids, acidic strength is gradually decreased. Then in the respective conjugate bases, the basic strength is gradually decreased. Like that. So otherwise, if you think about the respective conjugate base, the basic strength will be, you can say this is the stronger base is it is a stronger acid. Then it is a weaker base. Relatively, it is a weaker acid. Then it is a stronger base. The stronger base is one where electron density is maximum. It is preferred to take the proton. So that is called as a stronger base. So like that, if we are able to say the order of acidic strength, then automatically we can report the relative strength of the respective conjugate bases. Okay, so like that, the inductive effect is helpful to compare the acidic strength of the given alcohols. For example, here let me take what effect is involved here? The positive inductive effect is involved. Based on the positive inductive effect, we are able to compare the acidic strength of this list of compounds. Okay, now let me take, there is a situation where see, there is a situation, for example, we have compound like CH3 CH2OH. If suppose these hydrogens are replaced with fluorines, so then what happens? So in this case, I am saying this group is acting as an electron donating group and positive inductive effect is noticed. But in this case, because presence of fluorine, this is considered as an electron withdrawing group, minus A effect. So here positive inductive effect is noticed, here negative inductive effect is noticed. This group is responsible to pump the electron, but this group is responsible to withdraw the electron. That means in this situation the bond polarity is increases, so it is a stronger acid. So whenever in the case of acids, the electron withdrawing groups are there, the acidic strength is increased. The presence of electron withdrawing groups increases bond polarity, and ejection of proton is so easy. Otherwise, electron withdrawing groups decreases electron density in the respective conjugate base, then the species will be stable. Okay, whenever the conjugate base is stable, the respective acid is a stronger one. So no doubt, in any acid, the presence of electron withdrawing groups supports the acidic strength. Electron donating groups is acted opposite manner. That means decreases the acidic strength. That means negative inductive effect increases the acidic strength of compounds, but positive inductive effect decreases the acidic strength of the compound. So this is stronger than this one. And here, and they are interested to give the certain groups which are having, what about the withdrawing power of electrons. Electron withdrawing power for different groups is also given. Just given that the order of electron withdrawing power, that is minus A effect power. The minus A effect power is CF3 is first, then NO2, and then NR3 plus, and then Cn, and then halogen. So this is the power of electron withdrawing nature among the different groups normally. That means if you take, for example, some compound, either alcohol or carboxylic acid. So if you take some carboxylic acid, for example, you take CH3 COOH. This is a carboxylic acid. It is a polar bond, ejection of proton, that makes it is a stable one. So in order to improve the polarity, let me substitute different groups here. For example, in this place I just substituted CF3, COOH. Now let me substitute NO2 in this case. NO2. Always let me substitute here. We have one of the hydrogen is replaced. Compare. Here this hydrogen is replaced by different groups like this. This is here replaced with the CF3. That means the remaining part is same. CH2, CO, OH. Let me substitute here. One of the hydrogen is replaced by NO2. Let me take one more example. One of the hydrogen is substituted with trialkyl ammonia. Then one of the group is substituted with CN group. Now according to, by knowing the order of withdrawing power of these groups, we can see the negative inductive effect is more noticed in which case? The first case, because CF3 is a strongly electron withdrawing group due to presence of 3 fluorine atoms. So it is a very strong one compared to this one. That's why the minus A effect is very strong here. That means the acidic strength will be, the polarity of this bond will be more and ejection of proton is so easily. Otherwise if we take the respective conjugate base, it is in the form of like this. So when the strong electron withdrawing groups is appeared, the negative charge is diminished and the species is stabilized. Whenever the conjugate base is stable, the respective acid is stronger. So in this way, you can view the minus effect is maximum at this part. The strongest acid is this one. So this is the order of acidic strength in this given species. So in this way, the inductive effect is sometimes helpful to answer the question of the given example. So some questions can be explained, answered by inductive effect. So where inductive effect is nothing but the movement of electron noticed along the single bonds. Okay. Now let me take one more example. You have like, let me take, there is some compound like alcohol or carboxyl. Let me put an alcohol. The bond polarity. That means in which alcohol the ejection of proton is so easy. That is dictated by one second a group substituted in that compound. If suppose here I substituted at the part of alpha, suppose here I substituted some chlorine, and then you take another compound, here alpha position, this is beta position, gamma position, delta position, like this. Alpha, beta, gamma, delta and epsilon like that. Now let me substitute in the place of beta position, chlorine. Let me take another compound. Let me substitute chlorine in the part of gamma position. So in these three compounds, in which case, in which case ejection of proton is so easy. So here this is responsible to withdraw the electron. That means it is acting as a minus A effect. Here minus A effect is happened. That means this highly electronegative atom makes polarizing of this bond, and the impact will be here also. So the highly electron withdrawing group is very near to this bond. That means the bond polarity is increased. And here it is at beta position, here it is gamma position. As distance increases, the impact of inductive effect is decreases, because it happens up to few bonds only. So as the distance increases, that inductive effect is diminished. So in that case, I can say, in this case, the ejection of proton is so easy because it is very nearer to the proton going to eject. It is very nearer to the OH bond, which is supposed to be polarized to eject the proton easily. So it is a stronger acid compared to this one. It is a stronger acid compared to this one. That means whenever you substitute some electron withdrawing group very nearer to the group, from that hydrogen is ejected. When you substitute that electron withdrawing group very nearer to that functional group, from that alcohol hydrogen is supposed to be ejected. So that one is a stronger acid. So based on the inductive effect is gradually decreases on moving away and away. That helps us to say which one is a stronger acid. So in this way you have examples of inductive effect. Let's take examples like there is a CH3 COOH. Let me take a situation here, CH2 which is substituted with some O minus, COOH. So here we can write this as even like this also, acetic acid. Here this is hydrogen, it doesn't have any kind of nature as electron donating as well as electron withdrawing. But in this case, it is a negative charge species. It normally is considered as an electron pumping group. So plus A effect is noticed. So that's why if you compare these two species, which species is a stronger acid? So here positive negative effect is appeared. That's why it minimizes the bond polarity of OH. So that's why the first one is stronger acid than the second one. Okay. Otherwise, in place of hydrogen, let me put OH, CH2, COOH. Now, we have the groups like a negative charged group. We have the groups like OH group. Now, this group is considered as a minus I group because it is not a negative charge species. It is an oxygen which is more electronegative than carbon. That means the function of OH here it is acted as a minus I group. Okay, its function is withdrawing. Its function is pumping. So here positive indicative effect, here negative indicative effect. So which is stronger acid? So this is stronger. The next one is this one. The third one is this one. Because here negative indicative effect, in this case neither positive or negative, but here positive negative effect. So we can give the order of acidic strength will be like that. So in this way the indicative effect we just consider. And let me take one more example dear student. For example, we just compare acetic acid with benzoic acid. So if we compare these two based on electronegativity of this group, here this carbon is sp3 carbon, but here the carbon is sp2 carbon. That means among these two groups, which group pumps the electron better way? The methyl group is a better pumping of electron compared to phenyl group based on the inductive effect. It is movement of electron along the sigma bond is less here, it is less here. Here more, the pumping will be more here, the pumping of electron will be more here, but here the pumping of electron will be less based on the electronegativity. That's why the acetic acid is a weaker acid compared to benzoic acid. I am saying that this group is pumps the electron very less extent compared to methyl group based on electronegativity of carbon. Here the carbon is sp2, here the carbon is sp3. So this group is better electron pumping group compared to phenyl. That makes the benzoic acid is stronger than acetic acid. So I hope you got some idea about the inductive effect, which is helpful to give the relative acidic strength of the given species. So